matter. This is quite a bit you already know, so you can think of it as review. Solid to liquid is melting, liquid to gas is vaporization or evaporation or boiling. Boiling and evaporation are simply two types of vaporization. They all mean the same thing. And then gas to liquid would be condensation or to condense something. And then a liquid to a solid would be to freeze something. If you go directly from a solid to a gas, you skip the liquid phase, such as when dry ice sublimates directly from solid to gaseous phase, that would be sublimation. And when you go from the gaseous phase or the vapor phase to the solid phase and you skip the liquid phase, that would be deposition. And an example of that would be frost on a cold surface if it skips condensation. So notice the way that the particles are arranged. Phase changes are all about particles. If you add some amount of heat, heat absorbed is going to make the particles move around more, become liquidy. And of course, if you keep adding heat, the particles are able to completely separate from each other and move around and hit the container walls. So you have to know the various areas of a phase change graph. This is a phase change graph. Now I'm using Celsius temperature. There are the corresponding Fahrenheit temperatures. 33 is the freezing point of 0, and then the freezing point of water is 214. Actually, that's 32 and 212, so I'm off a little bit. That's 32 and 212. All right, so let's say that you have a container, a closed container, and you have a big chunk of ice, and there's a thermometer that you put in the ice, and the water froze. When you get an ice cube out of the freezer, it's a good chance if you somehow could take the temperature of the ice cube, it's going to be less than 0 degrees Celsius. Most people have their freezer set to anywhere from -4 to -8, so the ice cube is actually going to be less than 0 degrees. So ice itself, if you measured the temperature of the actual ice internally, it's probably going to be less than 0 degrees Celsius. So notice over here on the graph, got our graph over here on the right, that on the graph, this corresponds to that. If we're heating it up, if we're applying heat, the temperature of that ice is rising from -4 to 0. It doesn't start to melt until it gets to 0. Now once it gets to 0, all of that ice is going to begin to start to melt. And while it is melting, the temperature will not change. The temperature will remain at 0 degrees Celsius, long as you're adding heat to it. Even if you didn't add heat, if the surrounding environment were warmer than the temperature of the ice, then the ice is going to be melting. The temperature won't be changing. So, however much ice you had, that will dictate how long it takes to melt completely. So that horizontal line there would be longer if we had more ice. It would be shorter if we had less ice. Once the ice has become all water, you've kept the heat on, you haven't changed the heat at all, then the temperature of the water will start to rise. That is area number 3. Once it starts to boil, and this is kind of a misconception, once a pot of water is boiling, the temperature does not change. So when you're boiling water, it's always going to be 212 or 100 degrees Celsius as long as you keep applying heat. Now the time required for it to boil, for that amount of water to boil, as we just stated, is going to vary depending on how much water that you actually have and how much heat you're applying. So that can affect the length of this line here. Now we're in a closed system. We usually don't boil water in the kitchen in a closed system. The water turns to steam and then it moves into the atmosphere around the pot, and then the temperature decreases a little bit. But if it were in an enclosed system, as long as we kept the heat on it, the temperature is going to continue to rise. It would keep rising until there's no reason for it to stop rising, as long as the heat was high enough for it to keep rising. But probably the pressure that's caused by the increase in temperature and increase in pressure would rupture the vessel that you were in. So a phase change looks like this: heating up the ice, then the ice is melting, to water, then the heating up the water, and the water is boiling, then heating up the steam. And the length of this depends on how much heat you're adding and how much stuff you have. How much heat you're adding and how much stuff you have. And that's it.